Okay, hi guys, welcome back to my YouTube channel. Sorry I've been like MIA lately, but I'm back. So this is 2.1 to 2.2 AP Precalc review. Okay, so basically 2.1 to 2.2 is all about finding the arithmetic or geometric sequence, and that's basically a function that you can plug in to find out like different stuff on like graphs. Okay, so our first question is find the 23rd term of the sequence. So here we're given these numbers. What do? We either find the difference or we find the rate. So we can see here that it is decreasing by -3. So that's a difference. So what do? That is our D for our arithmetic sequence. Okay, whenever there's a difference, it's arithmetic. And then whenever there's a rate, it's geometric. Okay, our equation, I always write down my equation. It just helps me like figure out what I need to plug in and whatnot. So AN is equal to AK plus D, and then parentheses N minus K. Okay, now we can plug in our numbers. This would be 7 would be 1, 4, 2, and then 3 is 1. Okay, so AN is equal to AK is our full term, and we'd use 7 for this one. So is equal to 7 plus -3 parenthesis N minus 1, because we're counting 7 as our first term. So K is equal to the term which we are grouping it with. Okay, now we distribute -3N. -3 times -1 is +3 plus 7 is 10. Okay, and then this is our formula. So now we have a formula. It is not asking for a formula, but it's asking for the 23rd term. But now that we have a formula, we can just plug in that number. So A to the 23 is -3 times 23 plus 10, which gives us -59. And we can use our calculator for this. So yeah, there it is. Moving on. The fourth term of the geometric sequence is 12. Okay, A to the fourth is 12. A to the sixth is 48. And we know there is a rate, so we're going to put R equals because it's a geometric sequence. So now we need to determine the general rule for the nth term of the sequence. So we begin by writing our equation, which in this case, since it's geometric, we write AN equals A times the base of N. And then this is K minus K. We don't have our zero term yet. Okay, and now to find the A5th term, all we have to do is square root 12 times 48, which gives us A5 is equal to 24. So we know our rate is 2 because 24 divided by 12 is 2. Okay, and now we can plug in our general equation, which would give us, oh, but it's asking for the general. This is not the general. The general is f of n equals, and then we pick a number. In this case, I'm going to pick 24, rate 2, and then n minus 5. All right, and now we need to find out our nth term. So we need to find the regular one that we can like plug in any number and solve for. So the only way I find this one is if I know the rate is 2, going backwards, it's the opposite. So it'd be half. It would be 1/2. So half of 12 for A3 is 6. Half of 6 for A2 is 3. Half of 3 for A1 is 3 over 2. And half of 3 over 2 is equal to 0.7540. So our flat out nth term sequence is 0.75 times 2 to the nth power. So there is our equation for that. And now we need to find the value of the 20th term. So we plug in 20 for our n, 0.75 to n, and then f20 is equal to 786,432. All right, and those are our answers for this question. Now, moving on, identify each sequence as arithmetic, geometric, or neither. Then you find the next two terms. All right, so over here, we see that it is increasing by 4, 4, and 4. So this is an arithmetic, and our difference is 4. And we know the next terms, in that case, if the difference is 4, it'll be 19 and 23. Because 4 plus 15 is 19, and 4 plus 19 is 23. All right, moving on. We see that this is decaying by 1/2. So that is a rate of negative 1/2. All right, and now we do the next terms. So negative 8 divided by negative 1/2 is 4. And then 4 divided by negative half is negative 2. Right, moving on. Here we see that this is increasing by 2, this is increasing by 3, this is increasing by 4. So it is not arithmetic. And then if we do 4 over 6, that gives us 1.5. If we do 9 over 6, that gives us also 1.5. However, when we do 13 over 9, that gives us 1.4 repeated. So it's not geometric, so it's neither. However, we can tell what the next numbers will be because they always seem to increase by 1. So 13, from the next number, it'll increase by 5. So 13 plus 5 is 18, and then 18 plus 6 is 24. So there's our answer for that one. Right? Use the following sequence for 4 and 5. And then here we have all these numbers. All right, we can tell that this is decreasing by 0.4, and then this is also decreasing by 0.4. And it's telling us find the common difference, so we know it's arithmetic. So D equals negative 0.4. And write the general rule. Okay, this is 1, this is 2, this is 3. Okay, the general rule, again, write your equation. AN is equal to AK plus D, N minus K. All right, now we plug it in. AN equals AK, which is 12 plus negative 0.4, and then N minus 1. Right, now we distribute. AN is equal to negative 0.4 N plus 12.4. Right, so there is our general rule. And now find the number of terms in the sequence. We know this is a closed sequence because of the brackets, so we plug in 6.4 for our y in the equation. And now we solve 0.4 n plus 12.4. We subtract 12.4 to both sides, and then we have negative 6 is equal to negative 0.4 n. We divide by negative 0.4 n on both sides, and then we get n is equal to 15. And that is how many terms are in this sequence. All right. Okay, and now for this problem, a company buys a piece of equipment for $60,000. The equipment loses 20% of its value each year. Okay, depreciates 20% means we grab our 1, which represents 100, minus 0.2, which represents the 20%, which gives us 0.8. So that is our rates. Company buys equipment and the equipment loses, yeah. And then write a general formula, f of n equals ab to the n power, which is a geometric function. So f of n, and then we have, oh my god. So f of n, and we have our starting point, which is 60K, and then our rate is 0.80 to the n power. So there is our general formula after n years. What would be the value after 4 years? Okay, that is f to the power of 4, 60,000 times 0.8 to the power of 4 gives us $24,576. All right. Remember, you can use your calculator. And then after how many years will the value be less than 15,000? Round your answer to the nearest thousand. Okay? So we set our equation equal to 15,000, 60,000.8 to the power of 4. We divide by 60,000 on both sides, and that gives us 0.25 equals 0.8 to the power of 4. And now all we have to do is, so now we could do it either this way, 0.25 equals 0.8 to the power of 4. We could do log 0.8 times 2.5 is less than n. Or we could plug it into our calculator and get the graph and then see where the graph is going and then where it intersects. And our intersection is at 6.213 years. Round it to the nearest thousand. And this is our answer. Yeah, I hope you guys enjoyed. Thanks for viewing. Bye.